Here we go with part 2 of the atom test. First, this was a fill in the blank kind of column, and I have a couple of the answers already marked here, I see, but the first one was the number of orbitals, that's beds in a d sublevel. So if we look at the sheet that we had used earlier, this little sheet right here, you can see that the s sublevel had one orbital in it. Back in the house picture, remember we had the little house picture with like this, and we had the first floor sunny room and the second floor sunny room, and we had the third floor sunny room and pink room. So the pink rooms are over here and sunny room is over here. The sunny rooms had one bunk bed in each room. The pink room had 3 bunk beds in each room. And each bunk bed held 2 people. Now there was no sunny room. This was marked as the kitchen on our little house packet, which really means there is no such thing as a first floor pink room. So this is 1S, 2S, 2P, 3S, 3P. So each box then is like a bed and holds 2 electrons. So pulling that out so we can see our picture, or our test, the number of beds in a d sublevel is 1, 2, 3, 4, 5. Never found in the valence shell. Okay, and what that means is, if you look at the first floor has a sunny room, the second floor is sunny and pink, the third floor is sunny and pink and dark. However, before we started to fill in the 3D, we began the 4S. So 4S came before 3D. Therefore, the highest or outer shell is the highest coefficient, and 4 is bigger than 3. 4 came before 3. Up here we have 5 is the highest level, which comes before D. It's not literally higher, but it's the bonding shell. The 5th energy level is considered outer shell. So the 5 is bigger than 4, and so 4 will not be in the outer shell. So the idea here was that the D sublevel is never found in the outer shell. The maximum number of electrons in the D sublevel, since there are 5 beds and each bed holds 2 electrons, that answer would be 10. There. And can hold a maximum of 6 electrons. That would require 3 beds. So 2, 4, 6. That would be the P sublevel, or the pink room. Can only hold 2 electrons at most. 2 electrons at most would be the S sublevel. So any of these S's only have 1 bed. One bed only holds 2 electrons. So that would be the S sublevel. The sunny room, that'd be that one. All right, next section of this test, an atom with 8 neutrons. So if it has 8 neutrons, probably it's not silicon-28. To do this one, you have to remember that the protons plus the neutrons is equal to the mass. So silicon-28, silicon has 14 protons. You can see it right here. Right there, 14, that's silicon. So if it has 14, and you know the mass is 28, we'd have 14 plus the neutrons equals 28. So that answer is not going to be 8, because 14 plus 8 is not equal to 28. And same thing, it's not going to be phosphorus, because phosphorus is going to have 15 protons, but a mass of 31. So for phosphorus is 15 plus N equals 31, and N would be 16. And if you're wondering where I'm getting the 15, let me show you really quick. So I'm getting the 15 for phosphorus because its atomic number is 15. It has 15 protons. So It's not, that answer's not that. So an atom with 8 neutrons, these three answers are kind of bogus because you wouldn't say 8 neutrons and the answer is electrons. An atom with 8 neutrons and the answer is nucleus, it wouldn't make sense. So it has to be carbon 14. And if you look at carbon on the periodic table, it has 6 protons right here. And if it has, so that would mean 6 here plus n equals 14. So 6 plus 8 equals 14, so that's your answer. So several things you had to think about there to be able to figure that out. It's not too complex, but you did have to think a little bit about it. Now, I've already addressed this atom with 15 protons. We said that was phosphorus a second ago, so that's got to be phosphorus 31. All right. The occupied space of the atom, go back to a picture I had earlier. Here's the nucleus. Here's the electrons around the nucleus, so the volume, the space occupied, that'd be the electrons, so you'd put an X right here. The charge of the electron cloud, go back to the chart I had earlier, which one of these three particles is negative? The electron. So the charge of the electron cloud would have to be negative. So you look for negative, and just move my window out of here. So charge of the electron cloud is negative. The massive part of the atom, but tiny, goes back to here. That'd be this little dot right there. And what's that little dot called? That is the nucleus. Okay, so we're looking at our choices here. That would be our answer for that one, the nucleus. All right, so now we're on the last section on this test, I believe. So the number of electrons in the valence shell of aluminum. So now you know a little bit more now than you did when you took this test. So if we go to the periodic table, aluminum's in this third tall column. Or you could have written out 13 electrons. So of the 13 electrons, I'll do it here, we'd have 2 electrons in the 1s sublevel. You'd have 2 electrons in the 2s sublevel. Then there'd be 6 in the 2p sublevel. That makes 12 so far. 2, 4, 6, 8, 10, 11, 12, and we have one guy right here. So the number of electrons in the outer shell are just the ones in the third energy level. So that would be 3s, which holds 2, and 3p, which holds 1. So 2 plus 1 is 3. And so the number of electrons in the outer shell would be 3. So you wouldn't put plus 3, you just put 3. Okay, the charge on an atom that loses 3 electrons. Now, if you lose 3 electrons, first of all, if you lose electrons, you're positive because it looks like this. I'm going to remind you why that's true. So if you have 13 positives in an atom, you also have 13 negatives. So the positives and the negatives would cancel each other. But if I lost 3 negatives, then 3 electrons, I'd be losing 3 negatives. So I'd have 13 positives and only 10 negatives. So now what is my overall charge? Well, I've got 3 more pluses than I do minuses, so the overall charge is positive 3. Plus 3. Next question, a charge on an atom that gains 3 electrons. Well, if you gained 3 electrons, just looking at the same one, now you'd have 16 negatives. So you'd have 3 more negatives than you do positives, so the charge would be negative 3 if you've gained 3 electrons. How many valence electrons in an atom of sodium? So 2 different ways you could do that. You know that sodium has 11 electrons. We know that because of the periodic table. Right there is sodium, and it has 11 electrons. So you could write the electron configuration and just go 1s, 2, 2s2, 2p6, 3s1. I'm just doing this thing again, like I did for aluminum, except I only had 1 in the 3s. Like I did for aluminum, except I just have 1 in the 3s. Or you just look at the electron configuration as a whole. Or the easiest way to find the number of electrons in the outer shell is just look at what column it's in. And sodium is in the first column, so it has 1 electron in its outer shell. So that answer is 1. an atom with 14 protons and 10 electrons. So there's 4 more positives than there are negatives, so you got a net charge of positive 4. And that was the end of that section of the test. So we'll stop that one.